Let's continue with our discussion regarding telecommunications, the internet, and wireless technology. This discussion about the second part, and we have here the types of telecommunications network. We have the term wide area network known as the WAN. This type of network that covers a large geographic area. So from one city connected to another city, and a country connected to another country. That is wide area network. When you say local area network, a network connecting information processing devices within a limited physical area, what does it mean? If one building will be interconnected, or one campus, and that is local area network. There is what we call virtual private network, or VPN. It is a secured network that uses the internet as its main backbone network, but relies on network firewalls. So I would like you to define network firewalls. And this type of network, it has encryption and other security features of its internet and internet connection, and those of participating organizations. My always example of virtual private network is the Netflix. Okay. We have here client server. It means PCs and workstations called clients are interconnected by local area networks and share application processing with network servers. And we have here network computing. Thin clients provide a browser-based user interface for processing small application programs. And we have here peer-to-peer file sharing software connects each PC to a central server or to another online user's PC. So from one computer to be connected to another computer is peer-to-peer. Or it could be a computer connected to one network printing device, that is peer-to-peer. Okay. I mentioned about virtual private networks. The term, it is a secure network that uses the internet as the main backbone network, but relies on network firewalls, encryption, and other security features. Okay, I mentioned that one already. This is the image of a, what do you call this one, VPN, quite blurred. And we have here an image of a client-server networks. The client sends a login request to the server, and the server will reply if that particular account can access the network. So we have here the functions of computer systems in client networks. In the client systems, it will provide user interface, perform most processing on an application. When we say servers, shared computation, application control, distributed databases. And we have here mainframe, large servers, central database control, security, directory management, heavy-duty processing. We have also the term user interface. Refers to network computer and other clients provide a browser-based user interface for applet processing. And we have your system and application software. Application servers for multi-user operating systems, web server software, and application software applets. And we have databases and database management. So in a computer system connected to the network computing, database servers for the internet or internet web databases, we have operational databases and database management software. So databases will be part of this network computing. And we have here peer-to-peer network. So from one computer connected to another computer, that's one network or another device to be connected. So this is an example of a peer-to-peer with online server, and the other one is no central directory server. So we have here the example of peer-to-peer, then we have the media connecting the two nodes. When I say the pure peer-to-peer network architecture has no central directory or server. So the file sharing software in P2P network connects your PC with one of the online users in the network. Then an active link to your username is transmitted from peer to all online users in the network that the first user encountered in previous sessions. In this way, active links to more and more peers spread throughout the network and more it is used. So when you request a file, the software searches every online user and sends you a list of active names related to your request. Instead of clicking here on one of this, automatically transfers the file from that user's hard drive to yours. So we have here telecommunications media. We have three types of wired telecommunications media. The first one is twisted pair wire. It is a copper wire twisted into pairs. And we have coaxial cable, sturdy copper or aluminum wire wrapped with spacers to insulate and protect it. We can find it at the back of your TV box. Then now we have fiber optics, one or more hair-thin filaments of glass fiber wrapped in a protective jacket. So these are the three types of wired media. So you will see here the twisted pair, this is the copper wire, and this is the fiber optic. We have another type wireless technology or unwired. We have terrestrial microwave. It is earthbound microwave systems that transmit high-speed radio signals in a line of sight path between relay stations spaced approximately 30 miles apart. Okay. Then we have communication satellites, high Earth orbit communication satellites placed in stationary geosynchronous orbits. We have also cellular and PCS systems, a geographic area divided into cells with one low power transmitter device per cell used to relay calls from one cell to another. And we have wireless LANs, high and low or low frequency radio technology installed in an office or building. And we have wireless web, that's wireless web-enabled information appliances accessing the internet, intranets, and extranets. You have also Bluetooth, a short-range wireless technology which is rapidly being built into computers and other devices. It serves as a cable-free wireless connection to peripheral devices such as computer printers and scanners. So this is the model of a wireless application protocol. And take note of this model. And I mentioned about telecommunication processor. We have here modem or modulator, demodulator. This device converts digital signals from a computer into analog frequencies that can be transmitted over ordinary telephone lines. And we have multiplexers. Allow a single communications channel to carry simultaneous data transmissions from many terminals. I mentioned about modems. These are the most common type of communication processor. Why it is modem? The process is known as modulation and demodulation. What does it mean? The other end of the communication line converts the transmitted data back into digital form at the receiving terminal. That's why it's called modulation and demodulation. So this is the area where the port where you are going to connect your modem in a computer or PC. We have here some telecommunications technologies. What are the capacity of modem, the capacity of digital subscriber line, the integrated service digital network, and we have your cable modem, local microwave, and home satellite. Kindly read the different technologies. We mentioned also about inter-network processors. The first one we have switch. This device makes connections between telecommunication circuits in the network. Then we have here a router. Taking a router is a computer. It has its own operating system, it has a memory, it has its own command line or interpreter. So router is an intelligent communications processor that interconnects networks based on different protocols. When you say protocols, sets of standards or rules. Then we have here a hub, a port switching communications processor. We have a gateway, connects networks using different communications architectures. So a multiplexer is a communication processor that allows single communication channel to carry simultaneous data transmissions from many terminals. So we have here the basic method used in multiplexer. The common way is frequency division multiplexing, or known as FDM. A multiplexer effectively divides a high-speed channel into multiple low-speed channels. The second way is known as time division multiplexing, or TDM. The multiplexer divides the time each terminal can use the high-speed line into very short time slots or time frames. So we have here an example. So if we need to have 8 telephone numbers for small business, we could have 8 individual lines sent to the building, 1 for each telephone number. So using digital multiplexer, however, we can have 1 line handle all 8 telephone numbers, assuming that we have an 8-channel multiplexer. Okay, so that's what we call time division multiplexing. So multiplexers work to increase the number of transmissions possible without increasing the number of physical data channels. That's the main objective of multiplexer. So we have here an image of a communications processors, how this router switches and connected to the network. Let's discuss about network management. The first one is traffic management. When I say traffic management, manage network resources and traffic to avoid congestions and optimize telecommunications service levels to users. Otherwise, we have security, provide authentication, encryption, firewall, auditing, and enforcement. We have also network monitoring, troubleshoot and watch over the network, informing network administrators of potential problems before they occur. We have here capacity planning, survey network resources and traffic patterns and users' needs to determine how best to accommodate the needs of the network as it grows and changes. Next, we have different network topologies. The first topology, when we say topology, is a network design. We have here the star topology. So ties end user computers to a central computer. There will be a central computer between, and it will control all the personal computers connected. Those personal computers or devices, we call it nodes. We have also the ring, ties local computer processors together in a ring. It means circular design on a relatively equal basis. And we have here the bus. Local processors share the same communications channel. So we have here images of ring network, star network, and we have here the bus network. This is a bus network. Next, let's proceed about network architectures and protocols. When you say protocol, standard set of rules and procedures for the control of communications in a network. There will be so many protocols like file transfer protocol, the HTTP, we have TCP/IP protocol, and we have POP or POP, and small mail transfer protocol or SMTP. All of these protocols will be discussed in your networks and data communications. We have also network architecture. This term refers to the use of standard protocols, standard communications, hardware and software interfaces, and the design of a standard multi-level interface between end users and computer systems. And the goal is promoting an open, simple, flexible, and efficient telecommunications environment. Then we have the term Open Systems Interconnection, or OSI. It has a 7-layer model that serves as a standard model for a network architecture. And as an IT student, you need to memorize the 7 layers of OSI, and you need to identify what are the different protocols under this OSI model. We have Transmission Control Protocol and Internet Protocol, or TCP/IP. It's a 5-layer telecommunications protocol used by the internet. So there are similarities and there are differences between the two models. So I hope that you are going to identify the different functions of each model. We have the term voice over IP or internet telephony. It is a practice of using an internet connection to pass voice data using an internet protocol or IP instead of using the standard public switch telephone network. So the voice will travel over the packet. So it is often referred to as voice over IP or VoIP. This approach makes use a packet-based or switch network to carry voice calls instead of traditional circuits where sorry for this, it's switch network. It should be letter T here, switch network. So VoIP allows a person to function as if he or she were directly connected to a regular telephone network even when at home or in a remote office. So the voice will travel over the packet going to the router and switches. It also keeps standard long distance charges because the only connection is through the Internet Service Provider or ISP. Quite blurred again here for the image, but you need to memorize the 7 layers of OSI. The first layer is the physical layer. The definition here, it provides physical transmission of data on the telecommunications media in the network. And we have the second layer, network interface. This is in the TCP IP model, but in the OSI, that is the data link layer. This layer supports error-free organization and transmission of data in the network. The third layer in TCP IP is Internet Protocol or IP, and it is equivalent to the network layer of the OSI model. Provides appropriate routing by establishing connections among network links. Next one is about host-to-host transport layer, and in the OSI, it is named as transport layer. It supports the organization and transfer of data between nodes in a network. The 3 layers of OSI, application, presentation, and session, this three belong to application or process layer of the TCP IP. When you say application layer, provides communication services for end user applications. When we say presentation layer, provides appropriate data transmission formats and codes. And we have session layer, supports the accomplishment of telecommunication sessions. So application layer, this is the environment where the user will work and communicate towards the computer, just like the web browser or a slide presentation. Then this is the 7th layer. The 6th layer, if you're going to save it or you're going to transform it in that format. So, for example, PowerPoint, it will be PPTX. So web browser, HTML, it will go to this layer, presentation layer. So these are these different layers of TCP IP and OSI model. We have the term bandwidth, classification of communication speed, the capacity of telecommunications networks. So there are 2 different transmission rates. We have narrow band and we have broadband. When you say narrow band, low speed. When you say broadband, high speed transmission rates. We have here different network topologies and their capacities. The minimum here for example, for wireless fidelity, we have here 11. This is the typical bytes per second or bits per second. Okay. So when you say standard Ethernet or token ring, we have the capacity. Please go over with these different network topologies and their typical maximum BPS. In switching alternatives, we have different types. I mentioned we have first one, circuit switching. A switch opens to a circuit to establish a link between the sender and receiver, and it remains open until the communication session is completed. When you say message switching, a message is transmitted a block at a time from one switching device to another. We have packet switching. A message are divided into fixed or variable length packets, and packets are sent across the networks. And we have the term here, cell switching, breaks voice, video, and other data pixels of 53 bytes and routes them to their next destination in the network. So summary here, organizations are becoming network enterprises that use the internet, intranets, and other telecommunications networks to support business operations and collaborations within the enterprise and with their customers, suppliers, and other business partners. The tool support here, telecommunications network, is moving toward open inter-network digital networks for voice, data, video, and multimedia. So if you learn about open systems with unrestricted connectivity using the internet technologies, these are the primary telecommunications technology drivers in e-business systems. And you've learned also that companies are deriving strategic business value from the internet, which enables them to disseminate information globally, communicate and trade interactively with customized information and services for individual customers, and foster collaboration of people and integration of business processes within the enterprise and with business partners. Summary also here, businesses are installing and extending intranets throughout their organizations to improve communications and collaboration among individuals and teams within the enterprise. Another one, publish and share valuable business information easily, inexpensively, and effectively via enterprise information portals. Next, develop and deploy critical applications to support business operations and decision making. You've learned also that the primary role of extranets is to link the internet resources of a company to the intranets of its customers, suppliers, and other business partners. So you've learned in this topic the major generic components of telecommunications network. We have terminals, telecommunications processors, communication channels, computers, and telecommunications software. That ends topic 6. So if you have questions, doubts, or other things that you need to be clarified, just send us an email. Thank you very much. Have a nice day.